Hey everybody, this is Peter of peterstestprep.com. Today we're going to learn everything you need to know about law of sines and law of cosines for the ACT. We assume you know your basic trig, SOHCAHTOA, sine, cosine, tangent, what all of those mean, and those are going to be in other videos. This is advanced stuff, but this stuff appears on almost every exam, so if you know this, it's probably an extra point for you on the math section. We strongly recommend you print out the handout, the worksheet that goes along with this lesson. You can access this handout in the description at the bottom of the video. Have it with you when you watch the video, follow along with it. When we tell you to pause and do a problem or two, do so, because the best way to learn the material is to practice it. All right, if you're ready, let's begin learning about law of sines and law of cosines. Best place to begin is on page 1 at the beginning. So here's page 1 of the worksheet, and we're going to zoom in and we'll start in the left-hand column where you would expect us to start. A couple of quick preliminary notes. First of all, for all problems in this section, let's assume to solve to the nearest tenth. One other thing we should make a note of is that your calculator, you should always have it, make sure it's set to degrees when you are taking the exam or doing practice. Many of the calculators, my TI-83, always defaults whenever it turns off to radians, so we always want to be in degrees. There's a little box here that gives you a summary of where we're headed. This isn't going to make any sense now, but I've put this on the front page so that when you refer back to this and study this, it'll make sense to you. We're going to learn the law of sines first, and you want to use the law of sines first if you can. It's easier than the law of cosines. We're going to see this again a little bit later on. So let's jump to number 1, and let's just talk about what the law of sines and law of cosines are. When you have a triangle and you're trying to find the missing pieces, if it's a right triangle, then you're going to use either the Pythagorean theorem, a squared plus b squared equals c squared, or SOHCAHTOA. We will assume here you already know how to use those. But what if you want to find a missing side or angle of a triangle that is not a right triangle? This is when you use either of the two formulas, the law of sines in some situations and the law of cosines in others. Before we jump into learning the rules, we need to have a firm grasp of triangle notation. Capital letters are for angles. So for example, we can call this triangle ABC. We're going to use lowercase letters to represent the sides opposite those angles. So opposite capital angle A, we put a little a, that represents side A. Little b goes on the side opposite angle B. Little c is opposite angle C. Our first rule, our first formula that we're going to learn will be the law of sines. The law of sines is easier to apply than the law of cosines, and so we always want to try to apply this first. Now, there exists a relationship for all triangles. A single proportion exists between each angle and its corresponding side. What I mean is, if you take the sine of any angle A and make a proportion out of it, divide it, that is, with the side opposite, little a, well, that's going to equal the proportion formed by the sine of angle B divided by little b, and the same holds for angle C and little c below it. Now, you're not going to use all three at the same time. This just simply tells us that you have this relationship and it holds for all triangles. And you can use this formula for any triangle. You don't have to use SOHCAHTOA. All right, how do we apply that? Let's take a look at the example here. And you'll notice there's two angles, a 56-degree angle and a 70-degree angle. Opposite 50 degrees, 56 degrees is the side labeled 8. So we're going to make a proportion here. Sine of 56 degrees over side 8 is going to be equal to the angle formed by the sine of 70 degrees and that divided by side x. All right, that's the law of sines. It's really, really easy. Let's solve this. We cross multiply. X sine of 56 degrees equals 8 times sine of 70 degrees. We're going to divide by sine of 56, so you get x equals 8 sine 70 over sine of 56 degrees. And when you run this through your calculator, I get x equals 9.06. or we'll round it to 9.1. This makes sense. This is an interesting way to tell if your answer makes sense or if your calculator is working properly or if it's set on radians by accident. You'll notice you should know that the greater the angle in a triangle, the larger the side opposite it. So since 70 degrees is greater than 56, we would expect the side opposite the 70 degrees, which is 9.1, to indeed be greater than the 8 that's opposite angle 56. All right, let's stop here and let's have you do problem 2A on the bottom of the page. We're going to use law of sines here. And in order to use law of sines, as we're going to see in a moment, if we want to put a rule to it, you always have to have one angle and the side opposite it. If you have that situation at least one time in your triangle, then you can use law of sines. So let's apply sine of 42 degrees over the side opposite 25 is equal to sine of 68 degrees over x. I cross multiply, I get x sine of 42, sine of 42 degrees equals 25 sine of 68 degrees, and divide by sine of 42. So x equals 25 times sine of 68 degrees divided by sine of 42 degrees, and run that through the calculator, and I get x equals 34.6. And again, that makes sense because 34.6 is opposite the larger angle, 68, then is the side 25, which is a little smaller than 34.6. It is opposite the smaller angle, 42. So again, that makes sense. All right, let's go to the next page. And here you're going to see two problems, 2B and 2C on the left side. Let's pause the video and let's have you try those two problems. Looking first at 2B, you probably noticed that you can't set up the law of sines quite yet. We have to do a preliminary step here. Let's just put in some angle letters here. Let's call this triangle CDE. We need angle C first, right? So you should know, and you should always recognize that if you have two angles of a triangle, you can always find the third angle. So here we have these two angles here. They add up to 136, which means since the angles of a triangle add up to 180, that's going to be angle 44. Now we can set up our law of sines problem. So sine of 44 degrees over y, the side opposite it, is going to be equal to sine of 30 degrees over the side opposite it, which is 12. Cross multiply, y sine 30 degrees equals 12 sine 44 degrees. Divide by sine 30, you get y equals 12 sine of 44 degrees over sine of 30 degrees. And when you run that through your calculator, you should get y equals 16.67, and we'll round that to 16.7 like so. Jumping down to 2C. Now here we're going to find the angle labeled theta, and there's 12 opposite the 72 degrees, so let's go ahead and set this up. So sine of 72 degrees over 12 equals sine of theta over 9, and we cross multiply. 12 sine theta equals 9 sine 72 degrees, and divide by 12. So I get sine of theta equals 9 sine 72 degrees over 12. So sine of theta is equal to 0.713. Okay, we have something new here. A lot of students I have found are a little unsure about what to do at this point here. We're looking for the angle. How do you find the angle? You know that the sine of the angle is 0.713. What do you do when the angle's missing? Well, this is where you're going to use your second trig function or second sine function. You use the second sine function or the second trig function, whatever it is, second cosine, second tangent, when the angle's missing. So in order to find the angle, we do second sine of 0.713. And that's going to tell us that our angle, when we spit it back out, is 45.5 degrees. Your calculator will print, or if on the test they wanted to not actually ask you for the answer, but what expression could be used to find the angle, you're going to use the little -1 sign. So if I say sine to the -1 and 0.713, it's the same thing as the second sign. In fact, that's what your calculator is going to show you when you use second sign. What the -1 means is tell me the angle whose sine is equal to 0.713. So it's the same thing, and we'll get our 45.5 degrees. That's law of sines. Let's go to law of cosines. So let's go to the top of the right side here. We're in page 2 still. Number 3, section 3, law of cosines. Let's start by just simply asking, is it possible to use the law of sines to find the length of the side labeled x in this triangle? Give you a few seconds to think that over. I'm sure you've been thinking deeply. The answer is no, we can't use law of sines here because I don't have any side and its opposite angle. So as we hinted at before, in order to use the law of sines, you must know the value of at least one side and its corresponding or opposite angle, and we don't have that there. So this is where we're going to use the law of cosines when you can't use the law of sines. Let's write it out. The law of cosines is memorable because it begins like the Pythagorean theorem, a squared plus b squared equals c squared. But then what I'm going to do is, because it's not a right triangle, we have to subtract a term here. So I'm going to subtract 2 times the product of a and b, these two sides that are here, times the cosine of angle C. How do you know where everything goes? Well, your starting point has to be the angle. So the key to a law of cosines problem, the key to setting it up, is to first determine the angle you will use. So let's say whatever angle you use is C and it goes there. The side that's opposite the angle that you're going to do is going to be by itself on the other side. If you follow this process, then this becomes easy to set up. Determine your angle first, then the side opposite it will be over here by itself on the other side of the equal sign. The other two sides will go in the A and B position. It doesn't matter which one you use, they're interchangeable. Let's take a look and see how this works. So use the example in the bottom right. Same triangle as we were looking at before. Again, you can't use law of sines here because there's no angle and its opposite side available to us. What you do have here is two sides and the included angle, and you may remember from your geometry, that's what they call the SAS situation. When you have SAS, that's law of cosines. We're going to use the 41-degree angle. So I start always by writing cosine of 41 degrees. It's important to do that. The side opposite it is the side that's going to be by itself on the other side of the equal sign. It's going to be x squared. Then Pythagorean theorem, x squared equals 8 squared plus 6 squared, and then minus 2 times the product of 8 and 6 times the cosine of 41 degrees. You do it all in one shot like that, and your calculator is going to be able to do this for you. Now you can just put all of this into your calculator at one time. You don't have to do it in pieces. And we're going to get x squared equals 27.547. And when we take the square root of both sides, we get x equals 5.2 rounded. And the important thing here is that you know which angle you're going to work with first. And I repeat, the side that's opposite it is going to be alone on the other side of the equal sign. And the other two sides, the 8 and the 6, it doesn't matter which one you put first here. They're interchangeable. All right, so let's go to the next page 3, and let's have you do problem 3A. 3A only. Pause the video and give it a try. Oh, this is a 79-degree angle, by the way, in case you can't tell. We have, once again, side angle side. That means this is a cosine or law of cosine problem. We're looking for side DE, so we'll put an X there. The angle we're going to use is a 79-degree angle, so I'm going to put a cosine of 79 degrees there. The side we're looking for is opposite it, that's X, that goes there, X squared. And then the rest of it, well, nothing changes. X squared is equal to 7 squared plus 11 squared. Looks like Pythagorean theorem. And then subtract 2 times 7 times 11 times cosine 79. You put that into your calculator all at one shot. You get x squared equals 140.6. Take the square root of both sides, and you should get 11.9. Let's look at 3b together. Take a look at this triangle here. And can you set up a law of cosines equation, which we can use to find y, which is an angle, y degrees for this triangle? Don't solve it yet, just set it up. Go ahead and pause the video, write down your law of cosines equation to find y degrees. The angle we're going to be using is the y degree, so I'm going to write cosine y degrees. The side opposite it is 7 again, so that's going to be by itself on the other side of the equal sign, 7 squared. And then by now it should be easy to fill in the 5 squared and the 6 squared. Pythagorean theorem, minus 2 times 5 times 6 times cosine y. Now, extremely important point here. What almost every student does in the beginning when they're first learning to use law of cosines is you multiply and combine all of those numbers together on the right side in your calculator. 5 squared plus 6 squared minus 2 times 5 times 6. Don't do that. You can't do that because the last term here, the 2 times 5 times 6, is attached to the cosine y. What you need to do is actually subtract the 5 squared plus 6 squared over to the other side first. So you'll get 7 squared minus 5 squared minus 6 squared equals minus 2 times 5 times 6 times cosine y. All right, so that's important idea there. Don't get fooled into combining all of those numbers, everything that appears on the right side together in this situation. All right, well, we get minus 12. When we simplify that, equals minus 60 times y. I divide by minus 60. I get, should be cosine y, of course. I get cosine y equals 1/5 or 0.2. And I'm going to use second cosine of 1/5 because we're looking for the angle. The angle's missing, then you use your second function, second cosine function. And I get 78.5 degrees. So the trick to finding a missing angle when solving a law of cosines equation is to combine and subtract the two squared terms first, then dividing the coefficient with the cosine of the angle. Now it's your turn. Pause the video, and why don't you try question 3C. The angle that we're working with is theta, and the opposite side is 7. But hold on a second. This isn't a side angle side. Well, no, this is the second type of problem that you can use the law of cosines with, which is side, side, side. So when you have side, 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 and you're looking for an angle, that also means law of cosines. Well, let's set it up like we did before. The angle we're working with is just plain old theta, which means that the 7 squared is going to be by itself on the other side. Let's set up our law of cosines. 7 squared is equal to 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of theta. 49 equals 81 plus 169 minus 243 cosine theta. Again, subtract the 81 and the 169 over first. So that moves over to the other side. And quickly simplifying, again, negative 201 equals negative 243 cos theta. Cos theta, using second cosine, I'm not going to write all that down. Well, I'll just write down cosine theta is equal to 0.827. And then using second cosine, I get theta equal to 34.2 degrees. So let's take a look at that same box that we had on page 1, but now we also have it on page 3. Let's summarize where we're at. For a non-right triangle, although you can use this for a regular right triangle as well, we try to use law of sines first, but you have to have one side and its corresponding opposite angle. Otherwise, we're going to use the law of cosines, which applies when you have SAS or SSS, three sides given to you. Let's put this all together now. And we do a little bit more practice for this than we do some of the other topics because it's a little complicated and you need to practice this to get good at it. So let's have you write down the law of sines and the law of cosines here by memory. Don't look back, see if you can write them down. Law of sines, sine of angle A, so it's a capital A over little a, is equal to the sine of angle B. Big B over little b is equal to the sine of angle C over little c. And then the law of cosine, c squared equals a squared plus b squared. It starts off like the Pythagorean theorem, and then minus 2 times the product of a and b times cosine of c. By the way, these letters in the law of cosines are interchangeable. If I want to put a squared here, well, that just means I'm going to be doing the cosine of angle A there. And then the B and C are interchangeable in these other two positions. So I can do B squared plus C squared minus 2 times B times C like so. All right, let's go to page 4, section 5. And there's just some extra practice for you. And then we've got another little thing we want to talk about after that. So please stop the video and go ahead and do 5A, 5B, 5C. Follow all the steps that we've been practicing, and we'll come back and go over them. Just going back to page 3, section 4 here, where you wrote down the law of sines and law of cosines, I can tell you now this, which is that on the exam, the ACT gives you the law of sines and the law of cosine formulas. They give them to you in a problem if you're going to need them. That does not mean you should wait until the exam itself and hope to be able to remember how it works when you are sitting there doing number 55. You should know this stuff ahead of time. The more you know, the easier it is to get through this math section. Let's go through these problems then on page 4. Let's start with 5A. Now we have to draw our own triangle here. So let's do so. A, B, C is our triangle. BA or AB is 20, BC is 25, and the angle B is 55 degrees. We're looking for AC, so I put an X there. You have SAS. You have to decide first. Is this a law of sine or law of cosine problem? We don't have any angle in its opposite side, but we do have SAS, so it's law of cosines. The angle that we're going to be working with is 55 degrees. So we'll write cosine of 55 degrees there. The side opposite it is x, so x squared by itself on the other side of the equal sign. Well, we know how to fill in these other guys now pretty easily. And subtract 2 times 20 times 25 times cosine 55. Run this all through your calculator at one time, and I get x squared equals 451.42. And I take the square root of both sides and I get x equals 21.2. Hopefully you did too. Going on to 5b, here I do have an angle on its opposite side. So to find x here, we can use law of sines. Sine of 70 degrees over 5 is equal to sine of 52 degrees over x. We cross multiply, get 5 sine of 52 degrees equals x sine of 70 degrees. We divide by sine of 70, so we got x equals 5 sine of 52 degrees over sine of 70 degrees. I'm a little lazy. I don't always like to write my degree signs. And you run that through your calculator, and I get x equals 4.2, which makes sense here because x at 4.2 is smaller than side 5. And we expect that because the angle opposite the 4.2, 52 degrees, is smaller than the 70 degrees, which is opposite the other side. 5C, we have a triangle whose sides are 6, 10, and 12. They're looking for this angle of the measure of this triangle's largest angle. You should know the larger the angle, the larger the side opposite it. The larger the side, the larger the angle opposite it. So if we want the largest angle, that's got to be this angle opposite side labeled 12. All right, we have side, side, side. That is a law of cosine problem. Which angle are we working with? We're working with the x. So cosine of x, the side opposite it is 12. So that's going to be by itself on the other side of the equal sign. I get 12 squared equals 6 squared plus 10 squared minus 2 times 6 times 10. And remember to bring the 6 squared and 10 squared over to the other side first. Simplifying, I get 8 equals negative 120 cosine x. Divide by negative 120, I get cosine x equals 8 over negative 120. And I'm going to use second cosine of negative 8 over 120, and that should give us 93.8 degrees. I want to cover one more idea here. Number 6 on the top right here. Very often you do not actually have to solve a law of sines or law of cosine problem. Rather, you will frequently be asked simply to find an equation or expression that you can use to find the length of a line, or side of an angle, I should say, or an angle. Try these multiple choice problems, 6A and 6B. Pause the video and we'll come right back. You'll notice for 6A we don't have to solve for the missing side. We just have to find the correct expression, which may be used to find the length of AB. Let's put an X there. Well, a good place to always start is it law of sine or law of cosines? We have side, angle, side. So law of cosines, which means we can cross out C and D. Setting this up, we're using cosine of 44 degrees, which means the x squared is by itself on the other side. And we set the rest of this up. Again, you know this by now. X squared equals 6 squared plus 7 squared, Pythagorean theorem, minus 2 times 6 times 7. And if we look at our answers A and B, we can see that with answer A, we have minus 2 times 6 times 7. In answer B, it's plus 2 times 6 times 7. So if we were to take the square root of both sides to find x, it would have to be the one with the minus sign. So answer A is our correct answer. Finally, going to 6B, well, all of our answers are law of sines. Luckily, we can use law of sines here because we have an angle 51 degrees and its opposite side. It's a length of 8. So let's just set this up real quickly. Sine of 51 degrees over 8 equals the sine of theta over 10. Cross multiplying, we get 8 sine theta equals 10 sine 51 degrees. Divide by 8. I'm just going to take the lazy way out there. Sine of theta equals 10 sine 51 over 8. Answer C. So that is law of sines and law of cosines. Keep the worksheet, the handouts. 3-hole punch them, put them in a binder, study them, know them when you go take your ACT. If you're looking to maximize your math score and you know this stuff, that's probably worth an extra point. Thanks for watching the video, and we'll see you next time.